In this video, I'm demonstrating a micro.bit-based password tool that teaches practical cybersecurity concepts by combining real hardware entropy with a desktop visualization and a password strength check. So first, I'll show the hardware setup. This is a BBC micro.bit connected to my Windows PC over USB, and the micro.bit is programmed in MicroPython to generate strong passwords using multiple randomness sources like button timing and accelerometer movement. And if you have a microbit v2, you can also mix in microphone noise as an additional entropy input. But in my case, the microphone telemetry wasn't reliable, so the current version focuses on accelerometer-based entropy, which still demonstrates the core idea well. On the micro-bit side, the logic is simple and educational. We continuously sample sensor values and timing using running time plus accelerometer X, Y, and Z readings. Mix those into an internal state using bitwise operations so that the randomness evolves over time, and then when I trigger generation either by pressing A plus B on the device or by sending a gen command from the PC, the micro.bit transitions through clear phases like PRE, GN, and post, where PRE is the entropy collection stage, GN is the password creation stage, and post is the settling stage. And it streams these state markers and sensor telemetry to the PC over serial so the desktop client can visualize what's happening before, during, and after generation. Now on the Windows side, I'm running a Python GUI client built with Tkinter, and technically it does three main things. It auto-detects the COM port for the microbit using PySerial. It reads the serial stream in a background thread so the UI stays responsive, and it animates a virtual microbit plus live sensor graphs using a canvas that redraws at about 30 frames per second. You can see here in the code we define constants for colors and UI timing. Then we use a queue to safely pass serial lines from the serial reading thread into the main Tkinter loop. And every frame the UI consumes those lines and updates internal buffers, specifically decks that keep a rolling window of acceleration values so the animation looks smooth. For the sensor protocol, the micro.bit sends lines like s:timestamp, AX, AY, AZ, and the client passes those into integers, calculates acceleration magnitude using a square root, and uses that to drive the shake animation of the virtual board. Meaning, the more the real microbit moves, the more the virtual one jitters and glows, so you get a live digital twin effect. For the password output, when a line starting with PW arrives, the client launches an animation that reveals the password slowly, character by character, with a slot machine style random character roll before locking each character into place, which is visually engaging for a demo and makes the generation event obvious on screen. And right after that, the client runs a simple strength assessment based on length and character classes, lowercase, uppercase, digits, and symbols, and then displays a strength label like weak, fair, good, or strong with a corresponding color. And if Paperclip is installed, it automatically copies the generated password to the Windows clipboard so I can paste it instantly into a password manager or a test login form. The other important part for the demo is the state visualization, because while the microbit is collecting entropy in PRE or generating in Gen, the GUI changes the background theme and the LED glow colors so you can clearly see phase changes, and this reinforces the cybersecurity concept that strong password generation depends on unpredictable inputs. So I'll physically shake the device and you'll notice both the acceleration bars and the virtual board motion spike, and that's effectively showing hardware noise being incorporated into the process. Overall, this project ties embedded systems and desktop software together in a clean pipeline. Micro.bit sensors plus timing provide entropy. MicroPython transforms that into passwords and sends events over UART serial, and the Windows client provides an advanced animated visualization, command controls like GEN and length updates, and a real-time strength indicator, which makes it a strong prototype for teaching password hygiene, entropy, and basic secure design principles while still being simple enough to understand and extend, for example, by adding password history, exporting to an executable, or improving the entropy and strength scoring logic as the next step.